All right, we're continuing here with functions. And what we're going to start to look at is the graphs of functions. Now, let's begin with a really useful idea called the vertical line test. So this idea is going to make perfect sense, I hope, when it comes to the idea of what a function was. So I know I've said this many times, but do you remember that a function means you put something in the machine, you only get one thing out? Well, if you have the picture, the graph, you can decide whether or not this is a function rather easily. And what you're going to do is use a vertical line. So imagine that you were running a vertical line or a ruler up and down anywhere on the graph. If you only hit the graph everywhere, it doesn't matter where you put your ruler, you hit the graph in one spot, then it's going to be a function. If your ruler hits twice the graph in two different places, it's not a function. And you say, well, why would that be? Well, it's kind of intuitive. The reason is because for 1x, so here if I'm holding my ruler at 4, I'm getting two different y's. I'm getting a y up here, and I'm also getting a y down there. Well, we know if you put 4 in the machine and you get out two different values of y, it's not a function. And so the vertical line test is a super easy way, if you have the graph, to see whether you have a function. At 2, I'm hitting twice. So if I put in 2 in the machine, I'm getting out two different values, so not a function. But if I'm over here on A, I put in 3, I'm getting one value out. I put in 0, I'm getting one value out. -4, so it's a function. Okay, so if we try these two, this can be a little deceptive. These arrows on the end mean this graph is going to go on slowly going up forever on both sides. So if I have my ruler, even as I extend my vertical line, I'm never going to hit the same place twice. This goes on infinitely up forever and ever and ever. But if I'm over here and I have my vertical line, well, actually I'm hitting in two places at the same time. So this is a function, but this one is not, because I'm hitting in two places at the same time. Okay, I'm sure you have the idea now, but you see this one would not be, because I'm hitting twice, and this one would. All right, now I'm not sure what this book does, there are about 5 or 6 basic shapes that we need to be comfortable with of functions. They're going to be super valuable, and that as we move forward, we see these shapes over and over again. They have applications. We can move them around on the graphs. And the first one is called, it's literally the most comfortable one for you, it's a line. If you did your vertical line test, you're going to see a line is a function. So just recognize this. Let me see. They're going to have us graph these, but we've done this before. So this is a function, and you would graph it by knowing that's your y-intercept and there's your slope. But lines are functions. Okay, so if we did this, we know this is a function. It got the special function notation. Usually we say y equals -3x minus 1, but it's a function, so I can put the function name on there. So we would start with our y-intercept. We would go down 3 over 1, down 3 over 1, and there's my line. A linear function because it passes the vertical line test. Okay, again, same thing. Okay, now do you remember that we can do this? I'm going to change this into, you can give that negative sign either to the top or the bottom as a fraction. So I'm going to go up 4, 1, 2, 3, 4, and back 1. So remember how this works. Up and down is the top, right and left is the bottom. Up is positive, and on the bottom, right is positive. So I'm going back. Up 4, back 1. Up 4, back 1. You could have done it the other way. You'd get the exact same graph. You could have gone with the negative, but I didn't want to run off the page there, so I gave the negative to the bottom. Okay, another one we're going to see is a constant function. That's just a horizontal line. So if you were graphing that, it's a horizontal line, but it passes the vertical line test, so we can give it the special function notation. It's still the same exact thing. So this is just the line. So that's the same as the line y equals 4. which means y is always 4. No matter where you are, it's always 4. That's a horizontal line. So I'm sure you know where this is going. So this is the same as y is -2. That's a horizontal line at -2. And it's a function. It passes the vertical line test. Okay, not sure what I need to say about that. I think you got it. Passes the vertical line test. Okay, this is kind of a repeat. So the identity function really is the same as just a line here, but it's a line with a slope of 1 over 1 and no y-intercept. So that's all that's happening. You get a diagonal line if you just have y equals x. And it is a function because it passes the vertical line test. Now here is one of the most important ones as we move forward in algebra and then and also into other subjects, physics and definitely calculus. X squared is a quadratic. It makes a parabola. So parabola is this U shape. Now you can graph this. It is okay for me that if you have memorizing these basic shapes we're going to talk through here is really important. And if you had x squared, I would be perfectly fine if you don't have the points lining up perfectly. But if you wanted to, so you knew that it makes this shape and you go through 0, 0, that would be good enough for me. But if you want to make this perfect, you can just pick some points. You put in -3, you square it, you get 9. -2. So they've just picked some points to plot it and then to graph it. So again, I don't need you to do that. I think it's fine if you just know that that shape makes the parabola. Just make sure, now mine's a little off there, but it's supposed to be going through the origin 0, 0. Now, you could plot points here and you'd say, okay, well, you'd square this. So what you're going to find out is that this, when you put a negative in front, it's going to just turn that parabola upside down. But if you weren't sure about that, let's plot some points. That's supposed to be an x. Okay, so now we're putting in, let's say we're putting in -2, -1, 1, and 2. Put in -2. It's in the parentheses. So you've got -2 squared. Well, that's 4. It's going to get you -4. Put in -1 squared. It's going to get 1. It's going to get -1. You see what's happening here? It's going to flip it upside down. Same exact thing. You're going to get a 0 here. You're going to get the same graph, just this time turned upside down. That's what a negative in front will do. Okay, they're calling it the square function is all that we have here. I've never seen it called that, but same idea, x to the second. Now a cubic one is a little strange. It does this shape here. It's going to come up from the third quadrant, go through the origin, and then curl back up to the top. We could just do that by plotting points if you ever needed to. Again, if you have that basic shape memorized, that's good enough for me. So there's really not much more to do here. I would be perfectly happy if you just know that it does that. Now, what's a negative out front going to do? You can plot points and you're going to see the same thing. So this part's all going to be the same, but everything that came out is now going to have an extra negative in front. And what it's going to do is it's going to flip. So for any value of x, your y's are now going to be negative instead of positive. So what it's going to do is it's going to turn that basic shape upside down. All right, a square root function is an interesting one. So it's kind of important to know. So if you take the square root of 9, we've known all along that that gets us plus or minus 3. But here's the problem. If we're going to throw this function notation on the front, if we want a function that's a square root, we're not allowed to get plus or minus 3. That would not be a function. And so what they do to fix this problem is they say, hey, we're going to limit the value of a square root to its positive values. And so the reason that happens is, in order to use this f of x, that's the only way you could do it. Because if you got two outputs, it wouldn't be a function and you wouldn't be allowed. So the function version of a square root is only the positives. And it gets you this shape here. So again, we are limiting it to only the positive values, and it gets you something approximately like that. we've seen this before. The negative here is going to turn it upside down. And you test this with some points if you're not sure, but if you put in the value, the output you get is now going to be, instead of a positive value, it's going to be a negative, and so it's just going to turn it upside down. Positive y's are now negative y's. It flips it over the x-axis. All right, another one. This is my favorite because it makes this nice, pretty v. This is an absolute value function. Remember what it does. Anything you put inside of it, after you clean up what's in there, it becomes a positive. So no matter what value of x you put in, the output you're going to get is a positive. And that's why we get this pretty v shape. Okay, so again, I don't need you to plot the points. It's okay with me if you just know that it makes the v, but you got to get it right. Make sure you get the right shape. And then I hope you're catching on to what would happen here. If we put that negative in the front, it's going to turn it upside down. Okay, those are the shapes. That is a good selection. When you move to college algebra, we'll throw in a few more, but that's the basics. So you should be responsible for those shapes. Remember, the vertical line test tells if it's a function. And again, with the shapes, you can either memorize the shapes or you could just plot some points like you did when you were first learning about lines. Either would be fine. I'm perfectly happy if you just memorize the shapes and you get me an approximate graph.